All right, so here come your next two sides, sides 5 and 6 of our review packet. We're still working on factoring. So when I go ahead and I take a look at this one, I'll go ahead and split my x's. X squared is x times x, and y squared is y times y. In order to get a negative 18, I have a positive and a negative. 9 and 2 have a difference of 7, so I know 2 is my positive, 9 is my negative, because I have more negatives than positives. Nothing else can be factored, so I'm finished with that one. Alright, I have x to the 4th. Because this is x squared, I know that that x to the 4th splits evenly, because my middle terms have a difference of 1x. I know it's a difference because the 6 is negative, so 1 is plus, 1 is minus. I get 6 with 3 and 2. I have more positives than negatives. This is a prime. This is not a perfect square, so that's factored as low as it'll go. So 12 and n, I look down here and I see no common factors. So this one is a factoring by grouping. So what I'm going to do is take out a 4 and an n squared out of this first, leaving me with 3n plus 1. Now, I already have 3n plus 1, but you see I wrote this 1 here. That kind of holds that place for when I factor out this common factor, 3n plus 1. That leaves me with 4n squared plus 1. If this had been a subtraction sign, this would have been the difference of two perfect squares. But since it's a plus, I know that's prime, and I'm done. Alright, so now notice the difference of the words I'm being asked to solve. So when I'm solving, what I need to do is come up with my values for x. So when I go to factor, the first thing I'm going to do is take out this x that I see, leaving me with x squared minus 3x minus 4 is equal to 0. And then this x trails along, and I'm going to break down and factor this x into x and x. Negative here means one is positive, one is negative. I get negative 4 by positive 1 times negative 4. These are all to the first power, so I can go ahead and set each of them equal to 0 to solve. So x is equal to 0, x is equal to negative 1, and x is equal to 4. Now when I write this as a set of solutions, I can go ahead and draw my braces and say x is equal to, and if you want to be absolute, you should probably list from smallest to greatest. Alright, you solve anything higher than the first power by setting it equal to 0, so that you have the ability to use the 0 product property. This is the difference of two perfect squares. So when I factor the difference of two perfect squares, I have a sum and a difference. And I'll put the square root of my first term, square root of my second term. So this is the sum, so I can't factor this down anymore. This is a difference, but that's not a perfect square. So I'll set each factor equal to 0. Now I know if I looked at the graph of this, I'm going to have some imaginary solutions and some irrational solutions, because here's my imaginary ones. When I take the square root and I take the square root, I'm going to have x is equal to plus or minus I root 5. Those are going to be imaginary solutions. X squared is equal to 5. X is equal to, when I draw the square root, I have to include the plus or minus the square root of 5. That's an irrational number, somewhere bigger than 2, less than 3. So those are my final answers there. All 4. I have 4 values of x because I have x to the 4th power. All right, so we'll look at this one, and we'll go ahead and bring 12 over with the other factors, because you always want to set it equal to 0. So now we'll go ahead and factor by grouping. An m squared comes out, leaving me with 3m minus 4. And a 3 comes out, leaving me with the 3m minus 4. So my 3m minus 4 is times m squared plus 3. When I set each of those factors equal to 0, m is equal to 4/3. M is equal to plus or minus I, for the negative, root 3. So here are all of my values for m. I needed to find 3, so here's 1 and 2 and 3. Okay, so when I look here, I don't see a common factor that can come out. So I'll go ahead and do my magic number. So 7 times 6 is 42. So we're looking at 420 as my magic number, and it's negative. So I want to find two numbers with respect to 420 that have a difference of 32. So we'll go ahead and type in 420 divided by x. Go to my table of values and want to find two numbers that have a difference of 32. There they are. So it's going to be a 10 and a 42. I have more negatives, so this 42 is going to be my negative 1. 7x squared minus 42x's plus 10x's minus 60 is equal to 0. Notice my first terms and my last term doesn't change. This middle term is rewritten as those two. So I'm going to go ahead and wrap it up in parentheses and factor by grouping. I'll take out a 7 and an x, and that'll leave me with x minus 6 plus, I'll take out a positive 10, and that's going to leave me with an x minus 6. So I'll have x minus 6 times 7x plus 10. So x minus 6 could be equal to 0. X could have a value of 6. 7x plus 10 could be equal to 0. 7x is negative 10. X is equal to negative 10 sevenths. It's a quadratic, so I needed to find two answers. If I wanted to, I could write my answers as negative 10 sevenths and 6. All right, solve the following quadratics. So we'll have 4 more opportunities to solve. If it's a simple quadratic, I'm going to go ahead and factor. So I've got k and k. I want to try to make 6. So I think about the factors of 6. I've got 1 and 6. That's not going to give me 4. I've got 2 and 3. That's not going to give me 4. So it looks like I'm looking at a prime factor. So because it's going to be prime, I'm going to have to, I have two choices. I could either complete the square. So if it's prime, I can either, number 1, complete the square, or I can use the quadratic formula. So I'm going to complete the square on this one because it's a coefficient of 1, and this is an even number, so it's going to work out nice and pretty. And it's good for you to be reminded of how to complete the square. All right, so k squared minus 4k. I'm going to leave a blank for a number that works, and I'm going to subtract 6 to both sides because he doesn't work for me. My goal is to come up with this expression. So I'm going to bring k down. This sign is going to match. I'm going to take half of this number and I'm going to square it. So think about what you've just done. You've just given yourself the constant that's going to make this into a perfect square trinomial, which factors down into its binomial square. If I add 4 to this side, I have to add 4 to this side. So this is going to give me -2. I take the square root, and I get k minus 2 is equal to, I drew the square root, so it's going to be plus or minus. I comes out, and there's my root 2. So when I add 2 to each side, k is equal to 2 plus or minus I root 2. I would have gotten the same answer if I had done the quadratic formula, but I would have had some simplifying to do. Alright, so we'll go ahead, 8x squared plus 16x minus 42 is equal to 0. Now, because I have this 0 here, I can divide this entire by 2 and not have to worry about holding on to it. So 4x squared plus 8x's minus 21 is equal to 0. It just gives me smaller, friendlier numbers. I'm not going to complete the square for this one because it has this coefficient. That makes it harder. I'm probably going to do the quadratic formula. So my a is equal to 4, my b is equal to 8, and my c is equal to -21. So now x is equal to the opposite of b, plus or minus the square root b squared minus 4 times a times c all over 2a. So I'm going to go ahead and go to my calculator and calculate my discriminant value. So I'll go ahead and say 64 minus 4 times 4 times -21. The order of operations is going to do all this math first, which is what I want, and then subtract it. So I get 400. Hey, I could have factored this one. So second root of 400, and I know that because it's going to be 20. So we'll come up here to solve. My x is equal to -8 plus or minus 20 over 8. So x is equal to, let's see, -8 plus 20 divided by 8. X is equal to -8 minus 20 divided by 8. -8 plus 20 divided by 8. So x is equal to 3/2. -8 minus 20 divided by 8 is going to be x is equal to -3.5 is 7/2. So here's my solution set. X is equal to -7/2 and 3/2. Alright, we'll do this one. 3x squared plus 17. So 3x squared plus 17 plus 55 is equal to 0. Again, I don't know if this is factorable or not. It seems to be out of my friendly numbers. I'm going to go ahead and use the quadratic formula. A is equal to 3, B is equal to 17, and C is equal to 55. Oh, there is no x there. Hold on. I don't need the quadratic formula. Check it out. There's no x here. So I can, instead of bringing 55 over, I'm going to go ahead and combine like terms. So we have 3x squared minus 17, which means I'm actually adding. So 3x squared is equal to -72. Divide by 3, x squared is equal to 3 into 72, I want to say 14, but let's double check this math. Negative 55 minus 17. All right, divided by 3, 24. X squared is equal to negative 24. When I take the square root, x is equal to plus or minus, a 2 comes out, 24 has 4 as a factor, so 2. My I comes out, root 6. All right. Okay, so this one's already set up in vertex form for me. So we'll go ahead and say 2 times x minus 4 squared is equal to, subtract 2 from each side, 14. Divide by 2. Divide by 2, x minus 4 squared is equal to 7. All right, so I've isolated my perfect square, and I'm going to take the square root of each side. So that means that x minus 4 is equal to, I drew the square root, so that's plus or minus the square root of 7. That's not a perfect square, so the best I can do is x is equal to, I'll add 4 to each side, plus or minus the square root of 7. And those are my 2 answers. All right, moving on. We're on side 6, the back of page 3. Here's my f, my g, and my h function. So here's all these operations that I need to be able to do. So I want f minus h. So this is going to be equal to my f function, which is here, minus, and we want to use parentheses, my h function. So what's going to happen, because I'm taking away this whole thing, each of my signs are going to change. So 3x minus 1, my x squared becomes negative. My 2x becomes positive. Now I'm left with just combining like terms. So I have x squared, that's negative. 3 and positive 2 makes plus 5x's. And then minus 2. So that's when the functions are being subtracted. Okay, when you see this little o that's not colored in, this means times, this means a composite function. So we want f of g of 2. So what that means is they want 2 to go into g, and that result to go into f. So when we look at our f of g of 2, our f function is 3, and my x I'm going to leave a nice wide space for, because I'm going to put my g function in. Now here's the thing. I know that g is of 2. So my 2 goes in my g, and my g goes in my f. So that's equal to 3 times 4 plus 1 minus 1. That's 3 times 5 minus 1. That's going to be 15 minus 1. That's 14. All right. Now I don't have a value that goes into f, but I want h of f of x. So I start with my h function, which is going to be x squared minus 2 times x plus 1. And here's my h function up here. So instead of writing x, I'm going to insert f of x. So 3x minus 1 and 3x minus 1. So here's the thing. I don't have a value like I did up here. So the best I can do is write it in terms of x. My first job is to square this. So 9x squared minus, it's going to be minus 3x plus 1. Now I'm going to distribute this. Minus 6x plus 2 plus 1. Here's my FOILed. Here's my negative distributive, and there's my 1. All right, it looks like I have a total of 9x squareds. Here's minus 6x. Minus more is minus 12x's. Positive 1 plus 2 plus 1 sounds like 4 to me. So that's h of f of x. H times g of x is going to be equal to my h function, which is x squared minus 2x plus 1, times my g function, which is 2x plus 1. When I multiply these, I need to double distribute. So I'm going to have x squared times 2x, which is 2x cubed, x squared times 1, which is x squared, negative 2x times positive 2x, which is minus 4x squared, and this times this, minus 2x. Here I have a plus 2x, and here I have a plus 1. When I go to combine the terms, alright, so my 2x, and then I have my minus 3x squared. Look at this, my 2x's cancel out, and my plus 1. So that's going to be that composite function. Alright, so when I'm finding the inverse, remember I swap x and y, which means my x goes here, and my y goes there. And then my job is to solve for y. So I'm going to add 5 to each side. And then I'm going to go ahead and multiply each side by 3. So 3x plus 15 is equal to y. So my inverse is going to be equal to 3x plus 15. If I were to graph each of these on the coordinate plane, they would be reflections over the line y is equal to x. Alright, swap x and y. So my x goes here, and my y goes here. So subtract 4 from each side, divide by 2. So I have x minus 4 over 2 is equal to y squared. Take the square root, take the square root. So then my y is equal to plus or minus the square root of x minus 4 over the square root of 2. I have to rationalize this. Square root of 2 times the square root of 2. So I'm going to go ahead and have the square root of x minus 4 times the square root of 2 over 2 is equal to my inverse. So let's clean that up a little bit. My inverse is equal to the square root of 2 times x minus 4 all over 2. Don't forget our plus minus. Don't forget our plus minus. Alright, when we're dividing, we're going to go ahead and use synthetic division. So we want to make sure we use our coefficients, and we want to make sure we remember there's no x cubed coefficient. So we're going to go ahead and we're going to divide by x minus 2. So we'll go ahead and say 4, it goes here, 0 goes here, negative 2, and 1, and negative 1. So when we're dividing by this factor, we're going to go ahead and use the positive value, which would be the solution. So we'll go ahead and bring down 4. 2 times 4 is 8. 2 times 8 is 16. 2 times 14 is 28. 2 times 29 is 58, which means we have a remainder of 57. So our answer is going to be 4 constant linear quadratic cubed, 4x cubed plus 8x squared plus 14x plus 29, and our remainder is 57 out of the x minus 2 parts that went in. Is x minus 4 a factor of x to the 4th minus 16? So we've got a couple different choices for what we can do here. We can put 1, 0, 0, 4, 3, 2, 1, none. We can synthetically divide to see if 4 is the solution. So here's 1 and 4. Here's 4 and 16 and 16. And 4 times 16 is going to be 64, right? 64, and 64 times 4 is 256 minus 16. Yeah, we're going to go with no. Therefore, no, it is not a factor. If you wanted to talk about the second way that we can prove this, x to the 4th minus 16 is the difference of two perfect squares. So we can say x squared plus 4 and x squared minus 4. X squared plus 4 is prime, and x plus 2 and x minus 2 are the factors. None of those match up with that. All right, keep on working.